Okay, so let's look at primary keys, primaire sleutels, and its function. A primary key is a field in a table that makes that table, when you start entering data in it, so you start making records, that makes it unique. So it is a field that will make sure that the record that you have belongs to a certain person or to a certain object. So examples of this would be a passport number, cellular number, or any ID that you create that's going to be unique, like invoice number or something like that. Very bad example would be first name or last name, because you could have multiple people having the same first name and last name, and then you would not know that it's unique. So you cannot really say to which this record belongs. So the function is to make sure that you have a unique field that can identify to whom or to what a record belongs. That's the function of a primary key. Then, what is an index and what is the advantage of an index? An index is basically like an inhoudsopgave or like a trefwoordenregister, more like a trefwoordenregister, where the database tells you where you can find certain content of a specific field. So for example, let's say you want to find every single record that holds the term printer in it, in its description, for example. What that index could do, it could walk through all the records and then just note the number of records, the record numbers where the term printer is in. For example, it would say, okay, I have printer in record number 1, and record number 5, and record number 20, and record number 50. Instead of, when you search for printer in a database, it has to go through all of these records and look at all of them to come up with the record that have the term printer in it. An example of this would be like Google. If you type a keyword in Google, it's going to look at its index instead of having to go through all of the web pages in the world to find the keyword that you search for. So what it does, it makes an automatic trefwoordenregister, basically, an index of the things that you are looking for. And the advantage of that is that it makes searching a lot faster. Instead of having to go through all of the records. If you got a database of 1 million records and you only got like 10 of these records holding the term printer, it would be easier to stick them in the index, and then when you do a search, it looks at that index and immediately gives you the records where you can find this, instead of having to go and search through all of these records, these million records, to come up with it. So the advantage is faster searching. Consequently, this also means that your database is going to become bigger, because now you have the database and you have a separate index with the most searched like keywords. So this would be a disadvantage of that. En 13, wat bedoelen we met validatie van databasevelden? What this means is that if you put rules on a field, on what can go in this field, you are doing data validation. So you are making sure that, for example, if you have like gender, that you can only put in male or female, or if you have postal code in the US, for example, that you can only put numbers in there, or for example, if you have yes and no, that you can only put yes and no, and you cannot write something that doesn't make sense. You will notice this on very much databases that are related to like web forms. You fill in a web form and they will tell you, sorry, you entered your email address, but I don't see the @ in there. It doesn't follow the format, so it doesn't comply with the rules that are set. That's what we call data validation. It is for you to make sure that the correct data goes into the correct fields. Then, what type of data types do we have? Dus welke gegevenstypes kun je noemen? This is basically, you can define this yourself when you're doing access. For example, you will have to do this for each of your fields. You can say this is going to be a text field. You can put text in here, or this is going to be a date field. You can put a date in here, or this is going to be only numbers, or this is only going to be Boolean. Remember, Boolean is always yes or no, or one on or off. So it's only two choices. That's a Boolean data type. And there are several data types. When you are designing your fields in Microsoft Access for the practical part, you will have to set that data type. And you take the data type that makes sense. For example, for phone number, you could actually choose number, but you could also actually choose text if you want to use the plus, because the plus wouldn't work and then the validation rule, if you put it on numbers, it wouldn't work. So it depends a little bit on you and what you want to go into that fields. And if you put your data type, you're automatically already also doing a type of validation, because you're going to make sure that stuff that does not have to go in there cannot go in there. So that is data type. Remember also that text is normally for short text. I think the maximum that you can put into a text field is 256 characters. Whereas if you choose memo, it's also text, but it's going to be, you will have the option to write a lot more text in it. I think 65,000 or something characters that can go into a memo field. So that will be the difference between a text field and a memo field. And 15, what is a relationele database? Well, basically a relational database is a database that has tables that have a relation with each other. If we look at the example that we've been using with these, the cow database here, you see that basically here we have the tables, and here we see the fields, and we see that they have a relation with each other. So the moment we register a company, a bedrijf here, then the bedrijf gets coupled to a certain cow. Yeah? And that cow gets coupled to a certain jaarproductie. So that means like there is several tables. We have grouped these tables onto the fields that are logical for that table. And then these tables have a relationship with each other. If you make relationships, then how do you do this? Well, you take the primary key of one table and you stick it into the other table. Yeah? It becomes then there the foreign key of de externe sleutel of vreemde sleutel in Dutch. So als je de primaire sleutel neemt en je stopt hem in een andere, then you make a relationship between these tables. Wat is een Bachmann-diagram? Een Bachmann-diagram is a graphical representation of a database, but it only shows you the table names and the relation between these tables. So let me show you this Bachmann diagram. This is a Bachmann diagram. It has the table name and it shows this table. This customer has a relation with an order, and this order has a relation with an order line record, and in this order line we get products and we get shipments. Yeah. So this is a Bachmann diagram. You do not see the fields. This one, Bachmann diagram. And what we see here on this Bachmann diagram is that this one shows you actually one little arrow on this side and multiple arrows on this side, two actually, or it shows you one and then n. You can also use one and infinity symbol, which means this is a one-to-many relationship. So one customer can be linked to multiple invoices. Yeah? And then one country can be linked to multiple customers. Yeah? So this is a one-to-many relationship. We see this here. So you can either put one to n or one to infinity symbol, yeah, the reversed 8, or you can just put the arrows. On the one side you will put one arrow, and on the many side you will put many arrows. If it's a one-to-one relationship, then you put one arrow on one side and one arrow on the other side, or just a one here and a one there. Then you show that this is a one-to-one relationship. So Bachmann diagram, only table names and their relation. In a stroken diagram, there's another Bachmann diagram. In a stroken diagram, you will see actually the field names, and it will show you which field relates to which field in the other table. So here we got the primary key of this one. It's been put into the other table here, and then you see the relations. So you see all of the individual fields in a stroken diagram. That's the difference. Remember that both of them will remain ERDs. So this is a Bachmann diagram, this is a stroken diagram, and this is also a stroken diagram. But they all remain ERDs. Even the Microsoft Access, as I said before, the Microsoft Access relationship screen will be an ERD, because it's a graphical representation of your database, its tables, and the relationship between those tables. Alright, let's go to the next one. What is a one-to-one relation? A one-to-one relation is if you've got one record belonging to another record. So one record is in a table, and automatically you will have one record in the other table. Let me go back to this one here, bedrijven. If bedrijven here, if one bedrijf only had one cow, was only allowed to have one cow, then this would be, you have bedrijven record and it's related to one cow record. But naturally, in this case, one bedrijf can have multiple cows. So on this one, you would have one bedrijf with its primary key bedrijfsnummer, which is unique, and then it's related to multiple cows. You see that cow here, they given these cows a Q-number just to make sure that every cow is unique, so that we know who are we talking about, what are we talking about here. Yeah. So in this case, this would be a one-to-many relationship. It's not one-to-one. And then the last variant of relations would be a many-to-many, and this you find very much, for example, in web shops, where you have one customer that can buy multiple products, but that product can also be bought by multiple customers. So you get multiple products can be bought by multiple customers. So in that case, you would speak of a many-to-many relationship. So one-to-one, one-to-many, and many-to-many. That's basically the theory part. What you're going to get on your exams here is you are going to get databases, and you have to make diagrams of them. For example, a Bachmann diagram, and you have to put the relationships in there. So in a Bachmann diagram, you would have to show me the different tables, how they are related, and if they are one-to-one relations or one-to-many, by using the one and multiple arrows, or just using 1 to infinity or 1 to n on those sides, or 1 to 1 or n to n or infinity to infinity for many-to-many relations. So that's basically a part that you need to do for the graphical representation of databases.